Okay, let's look at the section 9.3. This section talks about one-to-one functions. Fancy word for one-to-one is injective functions, and also onto functions. And a fancy word for onto is surjective functions. All right, so let's look at the definition. All right, so we say function f from A to B is called one-to-one if whenever you have, say, A1 is different from A2, then this always implies that the corresponding element f of A1 is different from f of A2, right? So which means that if you have a function, in order to be one-to-one, you cannot have a situation like this. Let's say you have a set A and a set B. So you have two different A1 and A2 elements. Say you have B, right? So if the function maps A1 to B and A2 to B as well, this is a perfectly good function, but it's not one-to-one because when you have different A1 and A2 elements in A, and the corresponding element has to be different, but in this case A1 goes to B and also A2 goes to the same element B, which violate this condition. So this guy is not one-to-one. All right. So we can actually look at the equivalent definition. Instead of saying A1 is different from A2 implies f of A1 is not equal to f of A2. We can also say using contrapositive. So this is contrapositive. All right. So remember, not Q. So in this case, f of A1 is equal to f of A2 implies not P. So it has to mean A1 is equal to A2. All right. Sometimes the second definition is easier to apply. So we'll look at an example later. We're going to actually use this definition. All right. Then another definition is onto function. And this here's a definition. We say function f from A to B is onto, right, if, right, for all element B in the codomain B, there exists a corresponding element A in A such that f of A is exactly equal to B, right? Another way to say this is we have to make sure that the range of f is the same as codomain B. All right. All right, so that's the definition, which means that every single element in B has to have an arrow coming in. So if you look at the picture, so here's A. So let's say you have 1 and 2, and B might have element A and B, right? Then you can see that, say, 1 is mapped to B, maybe 2 is mapped to A, right? And you can see that the range of f is exactly the same thing as B. So you can see that every single element in B has at least one arrow coming in. All right, so let's look at a couple of examples. And the first one, we're going to define function from set of integers to a set of all integers by f of n is equal to n plus 2. All right, let's see if this function is one-to-one. All right, so we start with f of a1 is equal to f of a2. Right? So maybe let's say this is, oh, actually, maybe I'll write it this way. Right? This means, right, this implies that, okay, so function is n plus 2. So if you plug in a1, you would have a1 plus 2, right? If you plug in a2, you would get the a2 plus 2, right? Then you can just subtract 2 from both sides to end up getting a1 equals a2, right? So this means that the f is one-to-one because it satisfies this contrapositive condition right here. So therefore, so maybe I should say therefore f is 1, 2, 1. All right, so let's check to see if this is this function is onto. All right, so we're going to choose any element B in set B, right? So we know that, let's see, we have to make sure that, let's see, we know that there exists, maybe I'll write it here, there exists A. I'm going to let A to be B minus 2, right? B minus 2 is still an integer, right? B is an integer, subtracting 2, still an integer. All right, then such that, all right, look at f of a. F of a is equal to, of course, same thing as f of b minus 2, because a equals b minus 2. All right, if you plug it into the formula, is n plus 2, so n is replaced by b minus 2. Then you are adding 2 to it, right? So we can see that the negative 2 and the 2 cancel out. You just get b, right? So we just found a, which is namely b minus 2, which makes the function value exactly equal to b, right? So this satisfies the condition for onto, so f is onto, right? Let's look at the next example. All right, so function is 3n. It's a function g, and from a set of all integers to set of all integers. All right, so let's check. So f of a1 equals f of a2. So assume that f of a1 is equal to f of a2, which means that 3 times a1 equals 3 times a2. All right, so we can just divide through by 3 to get a1 is equal to a2, right? So this tells you that f is 1-to-1. All right. All right, so the onto part is actually a little bit tricky. So f of n is 3n, right? Can we find, for example, corresponding element to b equals 1? So let's say, what happens if, say, f of a is equal to 1, right? So, 1 is an integer. So there should be, if this was onto, there should be a corresponding element a so that the function is equal to 1, right? So I just picked 1, right? So which means that f of a is 3a, has to be equal to 1, which means that a has to be, so just divide through by 3, we know that the a has to be 1/3, right? But unfortunately, 1/3 is not an integer, so this guy is not an integer. But in order to get 1, a has to be 1/3, which is not an integer. So this is a contradiction. So therefore, you know that the function f here is not onto, right? Because this function will never have a value of 1, because in order to do that, a has to be 1/3, which is not an integer, right? That's it. I hope that this was clear.